Hello, 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 hello. Let me check what's going on. I don't think. What's going on here? Let me check. Where is the obvious studio? Okay, excellent condition, but my obvious studio is not showing. Where is it going? What's going on here? But my obvious studio is not showing. के भइरहेछ guys, के भइरहेछ यहाँ अनि मलाई केही थाहा भइरहेको छैन. I don't know anything about what's going here, but I'm on live. Oh, that's cool. It's in here. So let's start. What is my chat GPT? I have created everything about from here chat GPT and chat GPT 0. यो मेरो नोकर जस्तै भनौँ न होइन. नोकर पनि अलि भन्नु मिल्दैन. It's my, so what's going on here is the fnctl ioctl. Let's start about the purpose why fnctl used. Okay, so let's search from the Google. What is fcntl? Okay, fcntl. It's for file control. fcntl is a Unix Linux system call used to manipulate file descriptor, allowing you to control various aspects of an open file, like setting flags, obtaining file status, or managing locks. So purpose, what's the purpose of fcntl? fcntl function provides a mechanism to control open file descriptor. So it's a control over the open file descriptor only, allowing you to perform operations like changing flags. Non-blocking mode, this is very very important. What's the blocking mode and non-blocking mode? We will look after some couple of minutes. Obtaining file status flags or setting clearing file locks. We can also set the file lock and clear that lock. So file descriptor, what is file descriptor? When we open some file, then that file is registered, which file is open, uh, and what about the other flags status are mapped from kernel to user space. So some integer value written by the kernel to give what map. So let's check. The fcntl functions operates on a file descriptor which is an integer representing an open file. It represents the open file, which file is open is told by the descriptor. So command, the command argument specify the operation to be performed on the file descriptor, which type of operations we are going to perform, we are need to perform, which, so that is told by the command argument. So there are some couple of examples of the command which can be used on fcntl, which is uh, set flag. So it's a set flag, get flag, and set lock, Set file lock blocking or non-blocking mode. Set file lock on blocking or non-blocking mode. Also, we have retrieves. What is dots? Get lk. So it's lock. Retrieves the current locking status of a file. Return value. fcntl returns 0 on success and -1 on failure. So it's as usual. Most of the functions return 0 on success and negative on failure, with error number set to indicate the error. So it also indicates the error number, which is set to indicate the error, which type of error is occurred. Header file. The fcntl functions is defined fcntl.h header file. So let's check the manual. Man fcntl. So we have this manual. What is dots? Description. Name fcntl file control. It is our file control, and we have fcntl functions is inside the fcntl.h header file, and it's took couple of arguments, and this is the required arguments, and before these two all are the optional. So there we can also have the different argument which are optional, but these two, file descriptor and the command, are required. So it tells about the which descriptor, open descriptor, we want to perform these fcntl operations and what type of operations we are going to perform. Those two arguments are compulsory, but the other arguments are optional. It's the description. The fcntl function shall perform the operation described below on open files. So this, I said earlier, but I said earlier that fcntl is only for the open files, not for the closed file. The open files have these descriptors, and we perform the fcntl operations, file control operation, on that open uh, file. The file descriptor argument is a file descriptor. Argument is a file descriptor. So we pass the file descriptor to perform the fcntl operations. The available values for the command are defined in fcntl .h header files are as follows. There are a couple of arguments. So we are going to look at these command argument values. What types of command we uh, can pass on fcntl functions. So first is ftoop. Ft. What's that? Return a new file descriptor which shall be allocated as a described in section 2.014. I don't know what's file descriptor allocation. What does that? So there is no anything. So how can I do that type of? There is no Bhuman manual page. What's come here, bro? I'm not able to use the beam command beam motions in this manual page. So I'm using mouse. Expect that it should be lowest number available file descriptor greater than equal to third argument. Take as an integer of type the new file share any logs. So I don't get it. So this is not my interest. In this command I have no interest. Ha. So So there are some couple of important command that's must we need to know is get file descriptor. The get the file descriptor flag defined in fcntl that associated with the file descriptor. The file descriptor flag are associated with the single file descriptor and do not affect other file descriptor that refer to the same file. So we can get the file descriptor and we set the file descriptor. Set file descriptor flags defined in are associated with the file descriptor to the third argument. Oh, it is the third argument. This is not tells about the which argument, but set file descriptor is the third argument. So we can also set the file descriptor. Wow, this is cool. So we can copy the file descriptor which are referring to. So now I understand. We can set the multiple file descriptor which are referring the same file, and if we modify the one file descriptor, that will not change for the other file descriptor. This is not cool. So we have the one common file, and that common file is accessing by the multiple users. Then we can set the flag, status, locking, non-blocking for the each particular file descriptor. So one user can access that file with read only mode, and another user have the control over that file, so he can write and manipulate the contents file contents, and another user can access that files in non-blocking mode. Oh, nice. This is cool. This is cool, buddy. This is very, very cool things. So we can make the multiple file descriptor of the same file, so we can separately assign the privilege, permissions, that things. So otherwise, get flag. Get file descriptor, set file descriptor, and get file uh, get file status. Get file status. Get file status flags and the file access mode defined in fcntl. For the file description associated with the file descriptors, the file access mode can extract it from the return value using the marks of OCC mode, which is defined in fcntl. The file status flag and the file access mode are associated with the file description and do not affect other file descriptors that refer to the same file with the different open file descriptors. That's cool things. That's the cool things, very, very cool things. File descriptor that refer to the same file with different open file descriptor, that doesn't affect. The file return flags return may include non-standard file status flag which the application did not set. Provide these additional flags do not alter the behavior of the confirmed application. The set flag status flag defined again fcntl.hash header file. The file descriptor associated with the descriptor from the corresponding bits in the third argument take as an integer bits corresponding to the file access mode. The file creation flags as defined in fcntl that are not set in shell we ignore if any bits of the argument other than those mentioned here changed by the application. The result is unspecified. If the file description does not support non-blocking operation, it is unspecified whether the flag will be ignored. So this is used to set the flag. So other are not important for now. We also have the return value. If any error occurs, then it will return -1. There are also errors are defined. There are a couple of error, and here is the example. Oh, this also gives the example. That's cool. That's cool. I haven't seen the manual of something that also contains the example. Also, we have the application uses. So where we can use fcntl. Argument values of get file descriptor, set file descriptor, get flag, and set flag all represent flag values to allow for future growth. Application using these functions should do already modify write operations on them rather than assuming that only values defined by this volume are valid. This is common. You should forget that. On systems which do not perform permission checks at the time, all permission mandatory locks are obtained several reasons. Set group bits, copyright. This is for 6. Let's write a code. Know something about the fcntl. So it can be used over an fcntl. Is it on the open file descriptors, allowing you to control various aspects of open file like setting flags, obtaining file status, maintaining blocks. Uh, we have also a couple of most commonly used commands: set flag, get flag, and sets all file lock and blocking or non-blocking mode. Also retrieves the current locking status of the file. Those are the couple of very useful examples. And it fcntl returns 0 when it is success, -1 on failures. uh, fcntl is available under the fcntl.h header file. This is very important. So we have also have a manual page we have some earlier. And so how can we use that? How can you use this fcntl function get change flags like read only, append, or non-blocking mode? Block files to prevent multiple processes from modifying them at the same time. Duplication file descriptor Duplicate file descriptor dynamically. This is very important. We have seen earlier that we can duplicate the file descriptor, and we can change the uh, file what's saying the file properties to that file particular descriptor file properties without affecting the other uh, descriptors while they are referring the same file. So that is a very important term. uh, let's take us one simple example: changing the flag before and after modification. So we check the flag before modification, and we do some types of modification after changing that. So let's have a look this example. First we see about this example, and we look at example. So I'm opening this here. Network programming. File. Let's remove this. Let's open let's delete that file. And start from scratch. File control sudo rm file control. Let's create one directory called file control exists. What the heck is going here? It's not deleted. Oh, okay. Now it is deleted. So let's create the brand new folder, file control, and I am opening this directory in Vim. Let's create a file name fcntl.c. So first we need to include a header file. To use the fcntl functions, we should need to include the header file fcntl.h. So also we need the std.h and stdio. Those are two mainly important things. So first we declare a main function, then we can open one file. So in file descriptor equals open test file dot txt on read only mode. Read only mode. And let's check the, so if file descriptor is equals to -1 negative, which we all know that if the open function also return the -1 if it can't open a file or any type of uh, error occur during the opening the file, then it will return the -1 descriptor. So opening file will be open failed due to this reason. So let's, okay, then we can uh, okay, this will show the error. Otherwise we can print that value of the file descriptor. Printf file descriptor value %t at the last we can close the file descriptor always and return 0. So there is some error occur. What type of error occur? Too few arguments to function call, expected at least to have one. There is something wrong. I have forget this one. uh, so we placed this thing here, that's causing error or not. So let's check the manual. Man open. Hmm. Use open. Use anything wrong? I need open function. That's why ChatGPT is here. So I think there is something wrong that we need quotation here. Now it look better. So we fix that. We save the file and check run that file. For that we should need to compile the file using GCC object, and object name is also fcntl fcntl.c. Can run that file. So there is some error occurred, file opening failed, no such file directories because we didn't created a test.txt file. Let's create that. Test.txt. Hello, I am Mr. Canal. Let's see. And now we can run this. So our descriptor value is 3. So we are successfully open that file in read only mode. Can we get the flag? Which flag? Uh, we get the descriptor value, but we can't get the flag or status of that uh, of this descriptor. To get the flag, and so we open on read only mode. So we should need to get, how can get the status of that descriptor, get the flag of the descriptor. So let's have a look. fcntl.c. So environment say some int flags equals to fcntl, and we should not pass. There are two arguments which we need to always pass those two arguments on fcntl functions. So first one is the open file descriptor, which in our case is 3, and also the command which operation we are going to perform on that open file descriptor. So those two parameter are arguments are compulsory while calling the fcntl function. So first one is file descriptor, in our case this is fd, and which type of operation we are going to perform on that open file descriptor. So we want to get the uh, flag of that open file descriptor. So to get the flag, we have a command f get fl. So which we have seen previously. fnctl. Okay. This is fcntl. Save that. So we can see we saw the previously that here is, yeah, to retrieve the file status flag we can use the f get flag uh, command. So this will help to retrieve the file status flag. So it will gives a hex to get it. This we also print that here. uh, and while status file flag, so flag status, the flag status percentage d. So let's recompile that file and run that file. So we have a flag status called 3268. Let's copy this and convert to the hex value. So we can also get the hex value. For that we search that how to print hex integer value in hex in C using %x format specifier. Using %x format and %x format specifier in printf, we can print the hexadecimal values. So we can convert that decimal value 32768 into the hexadecimal using the %x format specifier. So we used %d for the integer. So now we can replace that. Can replace it with x. So recompile it. Then run that value. So we got the 800. So let's check. Again check. 0 flag. Flags register. We got the 800. What's here? Know something, but I don't understand what's written in mode flag. Series only. This is not. This is not what I am searching. What is mean 800 flag in Windows data? In status flags in the logs. We can use ChatGPT for that. I am getting 800 x value. Which mode is this? So this is very silly question because we set the flag on the read only mode and we open the file in read only mode so that it can be a read only mode file status. But we are also we can check that. If we know how to check that status of the flag, so we can do it, we are going to do it. But this is very silly, so we set earlier file status to the read only mode and we are checking what in what mode the file is opened. So this is very silly, but at some point yes, 32768 32768, we got that. Identify file mode, we compare it with the non-flag values. Read only mode 0 for read only mode. Asynchronous IO mode 32768. What the heck is going? Okay, okay. Let's check the code. So I set the flag on read only mode, isn't it? But it says that asynchronous IO mode. I'm using fcntl, which is not for the IO operations. Handle multiple file descriptor. Hmm. We can also check by this way. So let's check that. If flag and read only, then file is open read only mode. So if flags and oh async, let's check that, let's verify that, let's verify that. Compile and run that file. What's going on here? Why the print statement is not print? Check the code. Why those two are failed? I don't understand what's going on here. So I open a file on read only mode, and at the line number 14 and here we are checking file is opened on read only mode or not, but the print statement is not printed. That's mean our program saying that the file is not opened on read only mode. But in line number 8 we open file in read only mode. So what's going on here? Let's copy the code and give to the chat GPT to analyze the code. This is funny. This is funny, bro. I opened a file in read only mode. Then I am checking it is uh, open in which mode, but both the print statement STATEMA statement are not printed. What does it mean? So our code is not copied successfully. Let's copy the code first. Interesting issue. This is interesting issue. Let's break down step by step. Understanding read only not being printed. Your code is checking flags or read only. But this will not print anything because O read only is actually 0x0. Using bitwise AND with 0 always results in 0. So the condition is failed. Explicitly check the read only mode. Okay. So we can use like that. Why? SCC mode is 0x3 is a max that extract the excess mode. Oh, now the problem is not already set while opening the file. This condition will fail since you are open the file with read only and async is not included in the flag. What's going on here? Let's give ChatGPT another shock that our output is not 0 instead of 8000, which is for async. Our file is opening on asynchronous mode, but the output showing that it is opened in sync mode. The unexpected is because 0x00 is correspond to the async, which shouldn't be set when opening file with read only. Let's debug what's happening. The file descriptor value 3 and flag status 8000 file open in async mode. This means fcntl fd flag return 0x00, which is correspond to async, but you use only read only in open. So why this happening? Possible reason: file has async set by another process. The fcntl flags are inherited by child process. If another process or previous execution of a program set async, it will persist across open file. You can check reset it manually. File descriptor was modified before. If another program or previous code modified the flag, sync might already be active. Try to reset using Oh, we can. Oh, that's another thing. So we can reset the flag status by using this. What this called? Tilt. It's a not also. So bitwise end with flags. Flags, and we can reset the flag status by doing the bitwise end with flag on using the not. So this is important also. So we can reset the file status, then we'll check again. What's the going on here? So we can reset the flag here. Say fcntl file descriptor is fd, and command is okay. Here we can do that. Int so we don't need to redeclare the flags variable. uh, fcntl, we pass the file descriptor, and command is flags set f set flag flags and operation. Sync. What will be our output? Compile, flag status 0. Now we have only read only mode. What if we do the same thing again? Now we set the flags equals fcntl file descriptor uh, set flag. We have the flags and bitwise OR operation with read only mode. Recompile and run the program, so we can get the file status 0, because now it makes sense that uh, read only have the hex value 0 and decimal value 0, read on mode. So if we change to write only mode, then we can what we get. Let's change read only to write only mode. So change to write only. Recompile and rerun the program. So again we are getting 0. Why this is happening? Why this is happening? Doesn't it compile that? I don't know what's going on here. Let's check our code. Oh, what if I change to non-blocking mode? Non-block mode. Zero. Again zero. Now I can see some problem here. I don't know it will be work or not. I change to redeclare. Compile and run. We are getting zero. This is dumb things I ever seen. Let's print the decimal value. Percentage x. I'm getting zero. Is anything wrong here? Let's ask ChatGPT. ChatGPT also doesn't know what's going here. Why I am still getting zero? Okay. Oh, okay. But this is not a flag, you know. To get the flag, oh, it returns 0 on success, on -1 on failure. But if you want to get the flag value, uh, we should need to this function. So let's check again. We recompile and rerun that. Now we are getting 34816. Let's check the table here. Uh, let's check where is the table, 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 where is the check here. Give me more table corresponding to binary decimal. mm, non-blocking mode have 2048, but we are getting 34816. Again, this is unexpected. Again, this is unexpected. I am getting 34816. Convert to hex. Okay, okay. 34816. Decimal corresponds to the 0 wax at 800 hex. Decode the flag. So 34816 means asynchronous mode is on and non-blocking mode is on. So why it is again set to the asynchronous mode? I don't get the point. Let's check on Google. When I open a file in read-only mode, why async mode is also on? By default, when now is asynchronous commit mode, asynchronous file access. Again, give my code to the chat GPT. Here goes trying to remove async and add non-block, but we are still seeing the file open in async mode. Let's break it down step by step. Issue on code. Get current flag, remove the async, add non-block. Mistake. fcntl fcntl flags and does not update the flag correctly. Set flag returns 0 on success but does not modify the flag. It means your flag old value flags not updated one. Okay, old value of the flag not updated one. Remove async properly, apply not correctly. So first we need to okay. So we need to remove. Here is we are using this. So again, non-blocking mode. So remove this one too, because this return only 0 or 1. Remove the flag and we can get the flag here. So let's copy that and put here. So let's put here. Now we can get the output correctly. Mm, mm. Recompile and rerun that. Again, we can getting the same output. Right. So we get the current file flag and we set the flag and we can get the flag and again doing the OR operation with the non-block and we get the flag status which is again async mode is on. Why? Again, let's copy the code, keep the chat GPT. Again, I am getting the same output. Async mode, even after you try to remove it, let's investigate why this happened. Possible reason: kernel doesn't allow changing async for regular files. Async is manually used for socket, pipes, and terminals. On many systems, trying to modify async on regular file has no default in sync mode. Only change some flag, cannot change the file access mode. Read only, write only. Only modify certain flag like non-block. Try printing flag before and after changing them. I have done. Okay. Also need to print here. 7J. So 7J. Let's print this here. Before and after. So let's. Oh. Before compile and rerun this. Before file descriptor value is status is 32. Let's print on hex. Let's print on hex. So there is status. Status. Recompile and rerun this. So we are getting the same value 8080 and 8800. This is async mode. Oh, this is... Now print also check the flag status value here too. So now Don't let's copy that and print here. Removing. Let's recompile and rerun. Add 000, add 000, so turn it doesn't change. Why? Why this doesn't change? Why the flag value is not reset? Let's keep this to there. Still set? Why? Async is still set. Your output shows this. Initial flag is 800. Hex into async is set. After removing async, the flag did not change, meaning the system ignored your attempt to clear async. After adding non-block remained. Why you can't remove async? Regular file does not support async properly. Async is meant for terminal, sockets, or pipe. On regular file, it does nothing and cannot be changed. I've set file flag does not change all flag, only modify certain flag. The kernel may ignore async removal if it is not supported on that file type. How to verify file type? Try checking if the regular descriptor is a regular file or something else. Let's check. Let's check. Oh, we know the descriptor. Our descriptor we have the value is 3. This is for personal file, isn't it? File descriptor 3 is just the next available descriptor for standard input, standard output 1, standard error 2. Okay. When you open a file with open, the OS assign it the lowest available descriptor. 3 for the first open in the program, 4 for additional open. So FD3 is just means that it's the open file descriptor in your program after the standard. So what happen if we don't close the file descriptor? Descriptor value is 3. Rerun descriptor value 3. Descriptor. It will automatically closing the file descriptor, isn't it? File open and closed. Descriptor value is not changed. So let's put close back because it is a standard way. How to check what FD3 is referring to? If you want to verify what FD3 is pointing to use, is this. Path 56 as printf path size of path. So this is all about the fcntl functions. We can uh, set the flag, get the flag, and change the mode to the non-blocking mode, blocking mode, read-only mode, write-only mode, async mode, all those things. But there is something about the async. So is not for all types of file descriptor, all type of file. If we use async on that file, so it is not supported. Kernel simply ignore our command. So in our case, it is by default async is on, but when we try to reset the flag, the OS doesn't take our command seriously and ignore that. So we can also see from that this before file descriptor value is 3 and the flag status is 8000. Removing async file descriptor, again where we got the flag status 800, which means async command is simply discarded. So we are unable to change the flag, async flag off. So we are still getting 800, which is equivalent to the async mode is on, and the file descriptor value is 3 and flag status 8800. We set the flag to the non-blocking mode. How can we verify that? Here in above we have that. So yes, here 8800 is non-blocking. Non-blocking is edit, and again async is remained. Okay, so non-blocking mode 0800 is for the 0800 for the non-blocking, and 8000 for the blocking. When we can add those two, we got the 8800. So you got the point. 800 is for a non-blocking mode, and 8000 for async. So when you add those two, we get 8800, which is async mode is on and non-blocking mode is on. This is all for the fcntl function.